So here we will be discussing about binomial theorem or binomial expansion. Now, what is binomial? Binomial, you must have learned the concept of polynomials, binomial, trinomial, quadrinomial, like that. So this bi represent two terms. Do you know that?
Yes, ma'am.
So this bi represent two terms, and we are going to learn about the expansion of that in this chapter. So basically, two terms means our term will be like a plus b, or maybe a minus b. Here you can see two terms are there, or maybe x plus y, or two terms will be there. Binomial term will be there, and we are going to discuss here the expansion of that. That means there will be power n, there will be something as a power. So power n will be there, power n plus 1, whatever be the power, something as a power will be there. That's what we are going to discuss in this chapter. So binomial means two terms, and expansion means if two terms are there having a certain power, then how we will be doing the expansion of that we are going to discuss in detail in this chapter. So let's say you have already seen, like suppose we are having a plus b to the power 0. If the power is 0, anything having power 0 means what? Anything having power 0 will be
1.
if we are having a plus b whole square. You know the formula, there is a like you know the formula for a plus b whole square. You have already learned the identity of that. Why I am taking this identity over here? Because this is also binomial, right? And we have already learned the expansion of this type of identity. So the formula says it will be a square plus twice ab plus b square. Similarly, we have also learned the formula for a plus b whole cube. That is a square plus 3ab in bracket a plus b plus b cube. This is how we have learned the formula. However, you like we started writing this as a square plus b square plus 2ab like this. Both are same thing, but exactly if you will recall how it used to be written in the book, so it used to be written in the book in this form only, right?
Yes,
Twice
ma'am.
AB in the middle. Here also thrice AB in the middle and in this form. So here A square plus 3A square B plus 3AB square plus B cube. This is the expansion of A plus B whole cube. Now if we are having A plus B to the power 4, or maybe A plus B to the power 5, how we will be writing that? So if you don't know anything, binomial expansion, everything, we have not started yet. We will be starting and we will see how to use the concept of that. But from here also, can you see the pattern? One pattern is going on. Can you see when the first we are taking first term square, then we are taking first term's power, one power we are decreasing, first power 2 and then power 1 and then power 0. Can you see?
Yes, ma'am.
So basically what is happening in this expansion of a plus b whole square, first we have taken the first terms, the total power whatever was there. Then we have reduced the power. We just first it was 2, then we have taken 1 and then we'll be taking power 0. And the second term b, that's power, first time no b was there, that means first time power was 0, then power became 1 and then power became 2. Can you see the pattern?
Yes, ma'am.
And here we are getting twice AB like this. From where this 2 came out, That we will be discussing just after a while. Okay, but are you understanding how the pattern is going on for A and B? Similarly, if we will look at it here, if we will look at the cube expansion, we can say, okay, this was A cube. We can see first the power of A was what if the complete power, the total power. Then A power reduced, it became 2. Then A power 1. Then A power 0. Similarly, B power will start from 0. So first it was 0, then it became 1, then it became 2, then it became 3. Are you able to relate it with this?
Yes, ma'am.
A square B, AB square, B cube. So basically, how the pattern is going on for A plus B to the power 4, if I have to write, I know the first term will be having A to the power 4. Next term will be having A cube. After that, I'll be having A square. Then I'll be having A to the power 1 and then A to the power 0. Similarly, B power will start from 0. So B power 0, then B power 1, then B power 2, then B power 3 and then b power 4. This is what we will be getting. But with this, we will also be having the coefficient. Like previously, the coefficient twice AB was there in the middle, 2 was there in the middle. After that, 3 was there in the middle. That coefficient we will be discussing in a bit. But are you understanding this pattern?
Yes, ma'am.
Now, one more thing we must notice over here, when the power is 4, then how many term? When the power is 2, we are getting 1, 2, 3 term. When the power was 0, we have got 1 term. When the power is 3, we have got 1, 2, 3. Here, let's count 1, 2, 3, 4. When the power is 3, we are getting 4 terms. When the power is 2, we are getting 3 terms. Are you able to understand here?
Yes, ma'am.
Similarly, when the power is 5, we will be getting how many terms, Lena? How many terms we will be getting when the power will be 5? When the power is 0, we have got 1 term. One more. When the power is 2, can you see 3 terms we have got? When the power of a plus b whole square is there, a square plus twice ab plus b square. How many terms? 1, 2, 3. Can you see?
Yes, ma'am.
When the power was 3, we have got a square plus 3a, it's a cube, plus 3a square b plus 3ab square plus b cube. When the power was 3, 1, 2, 3, 4 term we have got. So when the power will be 5, how many term we will be getting?
6.
6 term. When the power is 7, we will be getting 8 term. When the power is 8, we will be getting 9 term. Are you getting it?
Yes, ma'am.
So two things we learned from here. One, we have seen the pattern. Which pattern? Like first, the first number is taking the complete power. Then it is just decreasing by 1. Then it is decreasing one more power, decreasing one more power. Like that it is going till 0. And the next term in the binomial is just starting from the 0, then 1, then 2, then 3 according to the given power. This is how the pattern is going on, right? So
Yes, ma'am.
like this, we can make the formula for any term. But one confusion is there that how we will be taking out the coefficient. Coefficient means here 3 is there, here 3 is there, here 2 is there. Is it just the power? No, it is not just the power. When you will expand a plus b to the power 4, so we can write it as a plus b whole squares power 2. Let's expand it a square 2ab b square, and that's power 2. If we will be doing, what we will be getting, a plus b plus c whole square, a square b square c square, a b b c c a, right?
Yes, ma'am.
Twice ab twice bc twice ca, right? So a to the power 4 plus this twice ab to the, what is the formula for a plus b plus c whole square?
A square, B square, C square, 2AB, 2AC, 2BC.
Perfect. Same formula we can apply for the above one, right?
Yes, ma'am.
A square, B square, C square, 2AB plus 2BC plus 2CA. So now if you will look at the coefficient, you can see here it's coming 4, here it's coming 4, and here it's coming 2 only, right? Is it 2? Yeah, only 2. Here it's coming 4. So coefficient we are still not sure. Okay. So what we can do for the coefficient, if you will look at the pattern here, I am saying that first one is having 1 as a coefficient. Next one is having 1, 1. After that, we are having this as a 1 and this as a 2 and this as a 1. I'm just, after a while, I'm explaining how we are getting this. 1, 3, 3, 1. Then we are having 1, 4, 6, 4, 1. So if you will see the pattern, can you see a plus b whole square is having this step? This one, a square plus twice ab plus b square. The coefficient of a square is 1. The coefficient of twice ab is 2. And the coefficient of b square is 1. Can you see it?
Yes, ma'am.
Similarly, if you will see a plus b whole cube, it is a cube, 3a square b, then 3ab square plus b cube. So it is coming from this, the coefficient, right?
Yes, ma'am.
Similarly, a plus b to the power 4. Let's see what was the expansion. It was, let's do it properly. That is a square plus 2ab plus b square. And that's whole square if we will do. First term square, the second term square, third term square, plus twice a b plus 2bc plus 2ca. So here what are we getting as a coefficient? This is not the arranged way. However, in arranged way, we will be getting this as a coefficient. 1, 4, 6, 4. This is what we will be getting, and 1. This is what we will be getting as a coefficient when we will arrange it in a proper manner. Okay, so basically it will come out as a plus b to the power 4 will come out as a to the power 4 plus a cube b. Here power of b was 0 plus a square b square. Power of b I am increasing and power of a I am decreasing. Can you see it?
Yes, ma'am.
Then a power I will decrease and b power I will increase. Then a power I will decrease more, that means it will be 0, and b power I will increase. So at last it will be b to the power 4. So we will be having the coefficient over here. The coefficient we will take from the Pascal's triangle. This is called Pascal's triangle, where 1, 1 will be sitting at the edge. First, we will be writing 1, then we will be writing 1, 1, and then we will be just adding the middle one, and then at the edges, we will be writing 1 only. This is called Pascal's triangle, and this Pascal triangle is also helping us to get the coefficient. Okay, so here for power 4, the coefficient will be 1, 4, 6, 4, 1. So that means the coefficient will be 1, 1, 4, 6, 4, 1. Are you getting it?
Yes, ma'am.
When the power is 5, let's do one more. When the power is 5, how we can expand it according to the pattern which we have observed, and by taking the help of course, Pascal's triangle for the coefficient. Let's see. So if we are having a plus b to the power 5, we will be having first a to the power 5 and b to the power 0. Now a power will keep on decreasing and b power will keep on increasing. So now a to the power 4 will get and b to the power 1. Then a to the power 3 we will get and b will increase. Then a to the power 2 and b to the power 3. Then a to the power 1 and b to the power 4. And then a to the power 0 and b to the power 5. One more thing we have observed here, when the power is 5, then the number of term will be 6. So 1, 2, 3, 4, 5, 6 terms we are having. Now the last concern is what will be the coefficient of each and every one. So coefficient of each and every one we will be getting from the Pascal's triangle. So if you will focus on Pascal's triangle over here, from here also you will be getting the same only. uh, Here we just have to do a bit of calculation. Here if you will do the calculation and if you want to match this with your a plus b to the power 4, then it will be a to the power 4 plus 4a square b square plus b to the power 4 plus 4a cube b plus 4a b cube plus 2 b square a square. This 4a square b square and 2b square a square will just get added, and we will be having a to the power 4 6a square b square plus b to the power 4 plus 4a cube b plus 4ab cube. So this is the formula we have applied for breaking a plus b to the power 4. Here I said you will get the coefficient, but this is not arranged way. The way we write a plus b whole square as a square plus b square plus 2ab, this is not arranged way. The arranged way, the proper way is a square plus 2ab plus b square. Okay, and this is how your Pascal triangle will also give the coefficient. This is how you have learned the identity when you have learned it in the very beginning, maybe in like class 7 or class 8, right? So this a to the power 4, b to the power 4, this one we need to arrange it. And if you will arrange it and if you will go back and will match it with the Pascal's triangle coefficient which we have taken and we have arranged it according to our understanding of the pattern, you will get this one and that one is same. So if we will be arranging a first, then one less power of a, this is 4a cube b, and then a square, this one 6a square b square, and then this one 4ab square ab cube, and then last b to the power 4. Here you can you see we are getting the coefficient 1 4 6 4 1. Can you see? And the Pascal triangle also says 1 4 6 4 1.
Yes, ma'am.
So pass, rather than doing, suppose I am telling you to find a plus b to the power 20, how you will do so? So now expanding is not possible just by using the rule. So what we can do, we understand the pattern, that the pattern says first term will take the total power, then it will keep on decreasing, and the second term of the binomial will just keep on increasing. It will start from b to the power, like it will start from the power 0 and it will reach the maximum power. This is how we will write the pattern, and from where we will be getting the coefficient of each and every term. This Pascal triangle will give the coefficient. Okay. So if we have to do a plus b to the power 5, all the term we have listed down, but still we need to write the coefficient. So Pascal triangle, if I am drawing it here, 1, 1, 1, just look at it carefully. Okay, then at the edges 1 will be there. 1, and then this summation of this 2. And at the edge 1 only. Then 1, summation of this 2. Here 1, 1 is not there, 2 is there. So summation of this 2 will be 3. Summation of this 2 will be 3 and then 1. Are you understanding, Lena?
Yes, ma'am.
This 6, this 4, this 1. Then can you tell me what will be there in the next row? 1,
1, 5, 10, 10, 5, 1.
perfect. What will be there in the next row?
1, 6, 15, 20, 15, 6, 1.
Perfect. This is what the Pascal has given the numbers in the form of triangle. And this for fifth power, we are going to use this row completely. Okay, and it says 1, 5, 10, 10, 5, 1. Let's write it. 1, 5, 10, 10, 5, 1. So this is how, just by understanding the pattern, we can write the binomial expansion of any term. But if we have to find a plus b to the power 20, and 20 till 20 we will be making the Pascal triangle, it will take a lot of time, right?
Yes, ma'am.
So for to avoid such scenario, we are having a formula in place. Now I am going to write the formula. Now I believe you will not get confused with the formula, because that's what we are doing and observing from the pattern also. So let's see the formula now. Now you already know the what will be the value, how to find the combination, permutation combination chapter we have already done. So you already know that, and how to find NC0, how to find NC1, how to find NC2, how to find NC3. These concepts we are going to use over here. So again, if I'll be writing the same expansion, a plus b whole square, that is a square plus 2ab plus b square. Here at first we are taking 2c0 a square. Then we are taking 2c2, 2c1 into ab. And then we are taking 2c2 into b square. This a square came out from the first term. Then power of a we have decreased 1, and b we have increased 1, and then b square. What about the coefficient? The coefficient, this formula was known to us, but we can also take it out from this relation, that is first 2c0, then 2c1, then 2c2. If you want to check what is the value of 2c0, please check it. It is 2 factorial by 2 minus 0. That means 2 factorial, that, and then 0 factorial, right, Lena?
Yes, ma'am.
2 factorial gone, and 0 factorial means 1. So that's why here the coefficient is 1. Can you see?
Yes, ma'am.
2c1, 2c1 means 2 factorial by 2 minus 1. That means 1 factorial and then 1 factorial. That means 2 factorial only in the numerator. That means 2 into 1. That means 2. From here only this 2 came out. Can you see?
Yes, ma'am.
And 2c2, if you will be doing 2c2, you will be getting 1. So from here only 1 coefficient is coming. So rather than writing the Pascal triangle, we can take the help of this combination formula to find the coefficient. Okay, if you want to check the same for a plus b whole cube, then we have learned the pattern. The pattern says first take the a cube, then decrease the power of a. It will be a square, then a to the power 1, then a to the power 0. But increase the power of b. So b is starting from 0 power, then 1 power, then 2 power, and then 3 power. But we were not sure about the coefficient. So for that only we have taken the help of Pascal triangle. But we realized that Pascal triangle is okay for 4 5 terms, like till the power is 4 5 7 8 9. But what about when the power is huge number? So we have figured out a way, and that way is saying that take n, like this as a power 3. So first take 3c0, then 3c1, then 3c2, then 3c3. Let's take it. First I am going to take 3c0, then 3c1, then 3c2, and then 3c3. All need addition. Is it okay?
Yes, ma'am.
And if you want to check whether this is true or not, let's check it out. So before checking it out, you need to learn one thing, that NC0 type of expression will always be 1. So be it 3c0, 340, or 2c0, whatever NCR. If R is 0, your answer will be 1. Okay? If you want to check it, you can check it or just learn it. You can check it also, obviously. And minus 0 means n only, and 0 factorial. So you are getting 1 only, right?
Yes, ma'am.
So NC0 will be 1. Keep it in your mind. Just lock it in your mind. That whenever we will be having NC0, it will be 1. So suddenly if I'll ask you, Lina, what will be the value of 5C0? Directly you will tell me it's 1. Okay?
Yes, ma'am.
If I'll be asking you, what will be the value of NC1? NC1. So the value will be N only. Okay? So is it clear till here?
Yes, ma'am.
And if I'll be asking you, what is the value of NCN? So the value will be 1. So 3 things you have to keep it in your mind, that NC0 is always 1, NCN is also 1, and NC1 is N only. This 3, just keep it in your mind. It will help you while doing the calculation fast. NC0, 1. NC1 means only N. And NCN means 1. Got it?
Yes, ma'am.
Let's apply the same in our question. So 3C0, 3C0 means NC0. That means 1, right? 3C0 will be 1, right, Lena? We don't have to check it, right?
Yes, ma'am.
AQ. B to the power 0, you can write it, you can skip it. Your wish, let's write it. Then 3C1, NC1 will be N only. So 3C1 will be 3 only. 4C1 will be 4 only. 5C1 will be 5 only. If you will calculate, you will get that number only. Okay? So that A square B plus 3C2, let's calculate it. 3 factorial by 3 minus 2, that means 1 factorial into 2 factorial is AB square plus 3C3 and Cn will be 1 only. A to the power 0 B cube. If you want, you can write, you can skip writing A to the power 0 B to the power 0. So first term is only A cube, second term is 3A square B, Third term is, can you see 2 factorial? If you will cancel it out, 3 will be remaining in the numerator, 3ab square. And the last term is b cube only. This is what we were having as a formula. This is what you have learned in class 7 or class 8, right?
Yes, ma'am.
So what we are trying to figure out, first we understood the pattern, how the pattern is going on, and then we were worried about the coefficient. So we have taken the help of Pascal triangle, but Pascal triangle is not helping that much, because when we have to take a like bigger power, when we have to do the expansion for the bigger power, the Pascal triangle will be huge. It will take a lot of time to write the Pascal triangle. So we figure out a way. Since we are already having the knowledge of permutation and combination, what we can do, we can take, at first we can take whatever power is there. If 5 power is there, so first coefficient will be 5c0, next coefficient will be 5c1, next coefficient will be 5c2, then 5c3, then 5c4, then 5c5. Getting it?
Yes, ma'am.
This is how we will be getting the coefficient. So this way we can write the expansion of any term. We will be able to write the expansion if we know this rule. Let's say you have to write the expansion of a plus b to the power 7, then you can write it. First a to the power 7 will be there, then power of a will decrease, power of a will decrease, decrease, then again it will decrease, then again it will decrease, then again it will decrease, and then it will just vanish. Power of b will be 0 at first, then power of b will be 1, then power of b2, power of b3, power of b4, power of b5, power of b6, and then totally power of b7. Here a to the power 0 is there. Now the coefficient, which was which we learned now. So first thing first will be 7c0, 7c1, 7c2, 7c3, 7c4, 7c5, 7c6, and 7c7. 7c7. All in addition. And this is how we have done the expansion of a plus b to the power 7. Got it, Lena?
Yes, ma'am.
And if we have to do now, let's write the formula. So the formula of binomial expansion says that if we are having x plus y to the power n, then first nc0, x to the power n, y to the power 0. Okay. Then nc1, x to the power n minus 1, y to the power 1. Then nc2, the power of x will decrease. Okay, first it was n power, then n minus 1 power, now it will be n minus 2 power. After that it will be, the power of x will be n minus 3, and it will keep on decreasing. Okay, at last the power of x will be 0. Power of y will keep on increasing. First it was 0 power, then it was 1 power. Okay, let's just take it out from the rectangular box because I want to show you the formula. Then power of y will be 2, then power of y will be 3. Like that the pattern will keep on going until or unless we will be getting the power of y as a n. Now what we have learned, that first coefficient will be nc0, nc1, nc2, nc3, nc4, nc5, nc6, like that, and the last coefficient will be ncn. Okay, this is the formula for doing the binomial expansion. Are you getting it?
Yes, ma'am.
And how you will keep it mind this formula every time you will be just decreasing the power, increasing the power? Yes, you can do that, but there is one more way. The way is, first write nc0, and then the power of x will be n minus 0. This minus this minus this. Power of x will be n minus 0. That means only n. And power of y will be only this 0. Similarly, nc1, if you are writing nc1, then the power of x will be n minus 1 and power of y will be 1. If you are writing nc2, then the power of x will be n minus 2 and power of y will be 2. If you are writing nc3, then the power of x will be, Lena? Yes, Lena, power of x will be this,
N minus 3.
and power of y will be
3.
only 3. If you are writing nc4, power of x will be,
N minus 4.
and y will be
4.
4. If you are writing nc5, power of x will be n minus 5, right? And y will be only 5. So this is how you can do the expansion. Okay, this is what the formula says, that you can learn it this way. So again I am writing the formula. X plus y to the power n formula says nc0, power of x is n minus 0, power of y is only 0. Then nc1, power of x is n minus 1, power of y is only 1. Then nc2, power of x is n minus 2, power of y is only 2. Then nc3, power of x is n minus 3, power of y is only 3. This way we have to go till what number? We have to go till ncn. Power of x is n minus n and power of y is only n. Getting?
Yes, ma'am.
This way you can learn the formula. How we reached till here, that you have understood. But what is the main thing? Main thing is this formula which you have to keep in mind. Okay? Now let me take one question. Just a second. Just a second. Okay, Lena, I am giving one question to you. Please try it now. Do the expansion of a plus b to the power 4 by using the above formula and a minus b to the power 4. If you want to see the formula, I am writing it over here. That is, you have to do the expansion of a plus b to the power 4 and then just do a plus b to the power 4, and a minus b to the power 4 also. Please do the expansion by taking this as a minus b in each and every term. The way we are taking y, instead of y, instead of b, you will be taking minus b in a bracket. Okay, so basically you are going to expand this as a plus minus b, that's power 4. Okay,
Okay, ma'am.
just do the expansion of this one and this one separately. Okay, I'm just give me a few minutes. Have you done it?
Yes, ma'am.
What you got as a plus b to the power 4?
A to the power 4 plus 4a cube b plus 6a square b square plus 4ab cube plus 4 to the power plus b to the power 4.
And what about a minus b to the power 4?
A to the power 4 minus 4a cube b plus 6a square b square minus 4ab cube plus b to the power 4.
Perfect. Now let me write the question. Why exactly we did so? So the question says, just a moment. The question says find a find a plus b to the power 4 minus a minus b to the power 4. Hence, evaluate root 3 plus root 2 to the power 4 minus root 3 minus root 2 to the power 4. So first find what is the value of a plus b to the power 4 minus a minus b to the power 4. So let's find it. Already you have found a plus b and a minus b to the power 4. Let's do the subtraction. If we will subtract it, can you see this term cancelling? Okay, it's subtracting, so each and every sign will change. So first we'll be having a to the power 4 plus 4a cube b plus 6a square b square plus 4ab cube plus b to the power 4. Now can I change the sign of each and every term over here? Because there
Yes,
is a
ma'am.
subtraction sign. So let's change the sign directly. We will be having minus a to the power 4, then plus 4a cube b, then minus 6a square b square, then plus 4a b cube, then minus b to the power 4. And let's cancel the term which are uh, like positive and negative. The same term. 4a cube b plus 4, 6 cancelled, b to the power 4, b to the power 4 cancelled. Is it clear so far, Lena?
Yes, ma'am.
So we are having 4a cube b and then 4a cube b. That we can say 8a cube b, can I say?
Yes, ma'am.
And we are having 4ab cube, 4ab cube, that we can say 8ab cube, right?
Yes, ma'am.
If we will be taking 8ab common, then we will be having a square plus b square, right?
Yes, ma'am.
Now by using the result of this one, we have to do the calculation of what? We have to do the calculation of root 3 plus root 2 to the power 4 minus root 3 minus root 2 to the power 4. Here root 3 is a, root 2 is b. Okay. So 8ab. So 8 into root 3 into root 2. Can I write directly from this
Yes,
result? Can I write?
yes, ma'am.
And in bracket a square plus b square, that means root 3 square plus root 2 square. Let's simplify it. We will be having 8 root 6 over here, because root will get multiplied with each other, but we cannot multiply 8. We cannot multiply 8 with the under root term. So it will be 8 root 6. In bracket it will be 3 plus 2. Is it clear?
Yes, ma'am.
Yeah. So it will be 8 root 6 into 5. That means 8 5 times 40 root 6. Is it okay?
Yes, ma'am.
So the value of this one is 40 root 6. This is our answer. How we did so? By using the formula or the expansion of, like, by doing binomial expansion. first we have solved whatever was asked, and then we have applied that rule to find the just required term, required expression. Any doubt here?
No, ma'am.
Okay, let's move to the next question. Now, if we have to do the expansion of a term like this, if we have to do expansion of 98 to the power 5, we can write it as, what can be written for that? We can write it as 100 minus 2 to the power 5, right?
Yes, ma'am.
And then we can do the binomial expansion of that. Here it says to find 98 to the power 5 by using the concept of binomial expansion. So this is how we will be able to apply the, like first just break it and then apply the binomial expansion, the formula. Okay. Now if we are having the question which is larger, 1.01 to the power 1. Let me check how many zeros are there. 1, 2, 3, 4, 5, 6. 3, 4, 5, 6 zeros are there. This one is larger, or 1, 2, 3. Yeah, 1, 2, 3, 4. This one is larger. Which one is larger? Yeah, which one is larger? How we will decide? Let's see. If we have to see which one is larger, here it's not possible to tell which one is larger. 1.0 to the huge power, will it be larger than 10,000 or not? We are not sure about that. We can use the concept of binomial expansion over here, which says that 1.01 can be written as 1 plus 0, 0.01. Can we write it like this?
Yes, ma'am.
And to the power whatever is there, 1, 2, 3, 4, 5, 6. Okay, 3, 4, 5, 6. Okay, let's do the expansion of this one. So the first term will be n, 3, 4, 5, 6, nc1, first term to the power n minus 1. So first term, whatever will be the power, it will be 1 only, right? Are you getting it?
Yes, ma'am.
1 to the power anything is just 1. So I'm not writing it. Or if you want, let me write it. 1, 2, 3, 4, 5, 6 minus 1 into the next term, that is 0.01 to the power. Okay, the first term is nc0, and then first term to the power this minus 0, and the next term to the power 0. Next term is nc1, first term to the power 1, 2, 3, 4, 5, 6, this minus 1, and the next term, that is 0.01, that to the power 1, right? Right,
Yes,
Lena?
ma'am.
This is how we do the expansion. The next term is 1, 2, 3, 4, 5, 6. This C2, 1 to the power 1, 2, 3, 4, 5, 6 minus 2, and 0.01 to the power 2. Like this, it will keep on going. Like, right?
Yes, ma'am.
Now, if we will be solving each and every one, at least till this much of term, then I told you that NC0 will be what? Always NC0 will be
1.
1. So this will be 1, right?
Yes, ma'am.
And what will be the NC1?
And
N. Okay, so this will be 1, 2, 3, 4, 5, 6. This is the answer for this one, right? Let's keep this much only. We are not going to calculate NC2. So what we will be having for at least two terms expansion, if we are simplifying at least two term, we are getting from the first term we are getting 1 to the power anything is just 1, and 0.01 to the power 0 is nothing. So first term is only 1. Can I say?
yes, ma'am.
And next term is 2, 3, 4, 5, 6. This 1 to the power anything is just 1, and 0.01, if you will write, it will be this, plus remaining terms, whatever is there. Okay. Now let's do the calculation of at least this two term. 1 into 1 is 1, and 0.01 into 1, 2, 3, 4, 5, 6. 6 zeros are there. Let me count it. 1, 2, 3, 4, 5, 6. Yeah, 6 zeros are there. So if we will be doing the multiplication, can you see 2 0 will get absorbed over here?
Yes, ma'am.
So we will be left with 1, 2, 3, 4. 1, 2, 3, 4. Plus remaining term. Is it clear so far?
Yes, ma'am.
So we will be having 1, 0, 0, 0, 1 plus remaining term, right?
Yes, ma'am.
Still remaining term is there, and this one is larger, or 10,000 is larger. So since we have expanded only two terms over here, and still just by expanding two terms we can say it is larger than 10,000. Can you see?
Yes, ma'am.
And still we are having a lot of terms, so definitely this 1.01 to the power, to the huge power, is larger than 10,000, right?
Yes, ma'am.
So we can say the question which was given, that 1 1.01 to the power 1, 2, 3, 4, 5, 6. This is larger, or 10,000 is larger. So we can say obviously this is larger, because here we have done the expansion, and after doing the expansion only two term is giving a number which is larger than 10,000, right?
Yes,
So we can say this is larger. Is it clear?
yes, ma'am.
We don't have to even expand the whole thing. Just by expanding it up to two or three term, you will get to know which one is larger or not. Okay. Now let me take one question. Suppose we are having 6 to the power n minus 5n. The question says, using binomial theorem, prove that 6 to the power n minus 5n. Okay, before this question, let me take one more question which will help you to understand the concept well. So using binomial theorem, prove that 9 to the power n plus 1 minus 8n minus 9 is divisible by 64. We have to show that this one is divisible by 64. How? By using the binomial theorem's concept. How we will be using the concept of binomial theorem? So whatever is given at first, this 9 to the power n plus 1, let's try to break it. How you will be breaking it? The way I told you, whenever you are having 98, you can write it as 100 minus 2, right?
Yes, ma'am.
If 98 to the power n is there, you can write it as 100 minus 2 to the power n, and then you can expand it. Similarly, if 9 to the power n plus 1 is there, and here 64 means you know it's 8 square. So let's break it in the form of 8 plus something, 8 minus something. Okay. So 9 we can expand it 1 plus 8. Yes or no?
Yes, ma'am.
and to the power n plus 1. Let's do the binomial expansion of this one. So what we will be having? Let's do it carefully. So first term is nc0. So can I write n plus 1 c0? Can
Yes,
I?
ma'am.
1 to the power this minus this, that means 1 to the power n plus 1 into 8 to the power 0. Then nc1, that means n plus 1 c1. Then 1 to the power this minus this. So if you will be doing n plus 1 minus 1 and then 8 to the power 1. Any confusion, Lena?
No, ma'am.
Then nc2, then n plus 1 c2, 1 to the power n plus 1 minus 2 into 8 to the power only 2. Plus, let's write one more, n plus 1 c3, 1 to the power n plus 1 minus 3, and then 8 to the power only 3. Like that it will keep on going. Yes or no?
Yes, ma'am.
Now we will be having n plus 1 c n plus 1. 1 to the power this minus this, that means 1 to the power 0, and 8 to the power n plus 1. This will be the last term, right?
Yes, ma'am.
Now if we will try solving at least few terms from the very beginning, which is easier to solve. So nc0 will be 1. 1 to the power anything is just 1. 8 to the power 0 is nothing, just 1. Plus n plus 1 c1 will be, this will be, what we will be having? N plus 1 c1 will be
N plus 1.
only n plus 1. Again 1 to the power anything is just 1, and 8 to the power 1 will be 8. Okay.
Yes.
Now if I am going to do one more step, uh, let me check whether it will help or not. It might help. Okay. So the next term will be n plus 1 factorial divided by n minus r. That means n plus 1 minus 2 factorial into 2 factorial. Okay. Into 8 square. Right.
Yes, ma'am.
Let's write the remaining term as it is. Plus we will be having n plus 1 c n plus 1. This will be
1.
1 to the power 0, 1. 8 to the power n plus 1, 8 to the power n plus 1. Got it so far?
Yes, ma'am.
So we will be having 1 here. We will be having here 8n plus 8 if we will expand this. And here we will be having like whatever is there. Uh, let's write it as it is, and then 8 square is there. Plus if we will feel that we have to expand this also, we will be expanding it, but let's see whether without expanding whether we can go ahead on the other side. I have written 1 plus 8 to the power n plus 1, right?
Yes, ma'am.
So here can you see 1 plus 8 to the power n plus 1 means it is 9 to the power n plus 1. We have expanded this only as this, right?
Yes, ma'am.
9 to the power n plus 1 minus, if we will be adding 8 plus 1 over here, it will be 9 over here plus 8 n over here plus the remaining terms like that, where 8 square is also there and this is also there, right?
Yes, ma'am.
So here we will, if we will shift this 9 and 8 n over here, we will be having 9 to the power n plus 1 minus 9 minus 8 n is equals to, let's not expand it, let's keep it as it is. So it was n plus 1 c2. This was n plus 1 c2. Let's see without expanding whether we can go ahead or not. Then the next term would have been n plus 1 c3 and 8 cubed, right? This is how it will keep on going till 8 to the power n plus 1, right? Right, Lina?
Yes, ma'am.
So here we will be having 9 to the power n plus 1 minus 9 minus 8n, and here this side we can take out 8 square common, because you know the power of 8 will keep on increasing till n plus 1, right?
Yes, ma'am.
So 8 square we can take out common. Why not? And what will be remaining term? The remaining term will be the coefficient first, then again the coefficient with 8 only, then again the coefficient with 8 square maybe, right? The remaining terms will be there. 8 square can be taken out as a common, right? Why we are
Yes, ma'am.
taking 8 square common? So that we can say that it is 64 multiplied with something k. This total, I am assuming this as a k. Okay. So now I can say that 9 to the power n plus 1 minus 8n minus 9 is equals to 64 into something. Using binomial theorem, prove that 9 to the power n plus 1 minus 8n minus 9 minus 8n minus 9 is divisible by 64. So if that is equals to 64 into something, then obviously the left hand side is divisible by 64, right?
Yes, ma'am.
If I am writing 15 is equals to 5 into 3, then this 15 is divisible by 5. If I am writing 24 is equals to 2 into something, then 24 is divisible by 2, obviously, right?
Yes, ma'am.
Similarly, I can say 9 to the power n plus 1 minus 8n minus 9 is divisible by 64. Let's summarize what we did. Here the question was 9 to the power n plus 1 minus 8n minus 9 is divisible by 64. That's what we needed to prove here. Okay. We realize 9 to the power n plus 1 can be written as 1 plus 8 to the power n plus 1. Whenever you are breaking, no Lina, always write first term as a 1. If that is possible to take, you can also write 9 as a 8 plus 1. But rather than taking 8 plus 1, please take it as a 1 plus 8. Okay.
Okay, ma'am.
So that initially only you will be getting the term 1 1 1 1, and you will be, since by solving 2 3 question, now you must have realized we need at least, when we are having a huge term, at least we need first 2 3 terms to simplify it to get to the answer, right?
Yes, ma'am.
So when we are breaking it 1 plus something, so initially 1 1 1 1 will be there, and that will maybe help us to reach to the answer easily. So 9 means 1 plus 8 or 8 plus 1. You are going to take 1 plus 8. Okay. So 1 plus 8 to the power n plus 1 I have written, and then we have just expanded it till few terms only. Okay. And the last term also we have written it as it is. Now we have simplified two terms, and the remaining term we have written as it is, as you can see. This also we don't need to expand. This was n plus 1 c2, and we can just write it as it is. So you can see just two terms I have expanded, and the remaining term I am writing as it is. Okay. Just by expanding two term, we realize that 9 to the power n plus 1, we have just written it as a 1 plus 8 to the power n plus 1. Now the given expression was 9 to the power n plus 1 minus 8 and minus 9. So from the right hand side, minus 8 and minus 9 we got. Now we have to prove that this whole thing is divisible by 64. So once you will look at it on your left right hand side expression, you will feel that first term is 8 square, next will be 8 cube, next will be 8 to the power 4, after that 8 to the power 5, till 8 to the power n plus 1. It is continuing in this pattern. So bare minimum 8 square can be taken out common easily from the right hand side. Once you will take it out as a common, you can say the left hand side is completely divisible by 8 square, that means 64. Got it?
Yes, ma'am.
So this is how we will use the concept of binomial expansion to prove such uh, like questions. Okay, let me see what is the next concept about. Okay, one more question. I am taking it from your book, and then we will be moving to the higher level concept. Okay, only 15 minutes is left. Just one more question. Let me give the hint. If I am having 1 plus x by 2 minus 2 by x to the power, what's the power? It's 4. Then we can expand it by using binomial theorem. But you know binomial is having two terms only. We have learned the formula for two terms. So you can customize this problem and you can take this two at a time and this after that. So you can write it as you are having the expression. You can write it as 1 plus x by 2 together and then plus minus 2 by x. This as another term to the power 4. This way you can write it. This is your A, this is your B. Now go and expand it. Will you be able to do this one?
Yes, ma'am.
Okay. Now the next concept says that whenever we are having x plus y to the power n, you know it can be written as nc0 x to the power, like the expansion you know already. So here, okay, let me write it, then only you will be able to relate what will be the general term. Okay, and nc0 x to the power n minus 0 y to the power 0, then nc1 x to the power n minus 1 y to the power 1, then nc2 x to the power n minus 2 y to the power 2, then nc3 x to the power n minus 3 y to the power 3 till what, then ncn x to the power n minus n is 0 and y to the power n. This is how we do the expansion, right?
Yes, ma'am.
Now here, if I'm talking about, can you see the first term? In the first term, this is the first term. Let me write first term is nc0 x to the power n and y to the power 0. Here the first term, this is r is 0. Can you see?
Yes, ma'am.
If I am writing the second term, r will be 1, right? Third term, r will be 2, right? Lena, the
Yes,
binomial
ma'am.
coefficient will be like this, right?
Yes, ma'am.
Now, here x to the power n minus 1, we can figure it out. X to the power n minus 2, we can figure it out just with the help of binomial coefficient. And y also power, we will be able to figure it out just with the help of binomial coefficient. Now, if I am telling you what will be the r plus 1th term, can I say it will be nc 1 less, that means only r? Can I say? Because third term it was 2, second term it was 1, first term it was 0, so r plus 1th term it will be only r. Can I say?
Yes, ma'am.
And what will be x to the power n minus r, y to the power r? Can we say?
Yes, ma'am.
This is the general term of binomial expansion. That is r plus 1th term will be ncr x to the power n minus r, y to the power r. X and y power we will get it, but only getting the coefficient, that will it be ncr plus 1 or ncr, was the confusion, which we have simplified it over here. Got it? It's just like the arithmetic progression, where the first term is a, the next term is a plus d, the next term is a plus 2d. So from here only, from the pattern only, you can say the nth term will be a plus n minus 1 into d, right?
Yes, ma'am.
Because the first term, there was Like if you will see the first term, there was 1 minus 1 into d. Second term, just a moment. Yeah. The second term, it is 2 minus 1 into d. The third term, it is 3 minus 1 into d. Similarly, we figured it out that n minus 1 term will be, nth term will be a plus n minus 1 into d. And from there, you have also got a formula. That is, nth term will be a plus n minus 1 into d. Right?
Yes.
So, at first I am saying the arithmetic sequence looks like a plus 2d, a plus 3d, a plus 4d, a plus 5d, a plus nth term will be a plus n minus 1d. Now we are saying there is a formula that nth term is a plus n minus 1 into d. From where we got this formula? Just by observing the general term, right?
Yes, ma'am.
Similarly, the binomial expansion, the first term is NC0, next term is having binomial coefficient NC1, the next term is having binomial coefficient NC2. Similarly, just by looking at our pattern, we are having a formula. What is the formula? The formula is r plus 1th term will be NCR, x to the power n minus r, y to the power r. Okay. Now, one more concept say this is r plus 1th term. We will be solving question related to it in the next class. One more concept I want to give you. Just a second. Have you done the concept of middle term? Like when we are having even number, how to find, like in statistics, have you learned how to find the median in statistics? Have you heard this word median?
Yes, ma'am.
Okay. So that way, that concept we are going to apply over here also. Just give me a second. Okay. So I'm saying to find the middle term, if you will recall, if you will recall the concept which we were using for finding the median, when one, two, three people were there, then we used to say that middle term will be this one, right? How we used to get, when the number of people are odd number, then there was a formula that we will be getting n plus 1 by 2th term, that will be the middle term, right?
Yes, ma'am.
So if the number of people are 3, then 3 plus 1 by 2, that means 4 by 2, that means second term is the middle term. So if 10, 15, 20 is sitting over there, then I can say second term, that means 15 is the middle term, right? And similarly, if the number of people are even number like this, suppose 10 is there, 12 is there, 15 is there, 20 is there, then there is another formula for finding the middle term, which says that when even number of people are there, then n by 2th term and n by 2 plus 1 th term, these two are in the middle. That means 4 by 2th and 4 by 2 plus 1th term, these two are in the middle. That means second term and third term are the middle term. And obviously, just by looking at this data, you can say these two are in the middle, right?
Yes, ma'am.
Here also, we are having the concept of middle term, which says that if n is even, then just a moment. Okay, if n is even number, one thing we have discussed in the very beginning, that means a plus b to the power 4 is there, then how many term you will get, Lena? 5 terms, right? 1, 2, 3, 4, 5, right?
Yes,
One
ma'am.
more term we are getting by doing the binomial expansion, right, Lena?
Yes, ma'am.
Similarly, when the number of term was 3, we used to get 4 terms, right?
Yes, ma'am.
When the power was 3, we used to get 4 term. When the power is 4, we used to get 5 term. When the power is 5, we used to get 6 term. Like that, we were getting the terms, right?
Yes, ma'am.
So when n is even, when the power is even number, the number of term will be odd. Are you understanding it?
Yes, ma'am.
And if the number of term will be odd number, then for the middle term, there is a formula which is n by 2 plus 1th term will be the middle term. So I am going to write the formula. Please don't get confused. If n is even, then there is only one middle term. Why? Because when you will expand it, you will be getting odd number of term. Okay, and eventually you will be able to figure out one term. Okay, one middle term, and that you will take it out from the formula n by 2 plus 1th term. Again, I am repeating, when n is even, you will be getting one middle term. Why? Because when the power is even, your number of term will become odd number. So easily you will be able to figure out which one is sitting in the middle. Getting it?
Yes, ma'am.
And the next formula says, when n is odd, then there are two middle terms, which are n plus 1 by 2th term and the next n plus 1 by 2 plus 1th term. Is it making